This is the instructional video for the use of the resonant test trailer. The test trailer will be run with 2 testing staff and 4 observers. The testing staff will complete a 132,000 volt or 132 kV test for the commissioning of a new high voltage feeder. At the beginning of the job, we perform the hazard assessment check in conjunction with the Safe Work Method statement for high voltage testing in substations. Through discussion with the work group, hazards associated with the work are identified and then assigned a risk rating.
Just a reminder again, we're in a zone sub, so we need hard hats, gloves and glasses obviously at all times.
Controls are then put in place to manage the risks and the new risk rating is recorded.
23, and we can drop that to probably 8 or something.
The work group then signs the hack document to show that they have understood the dangers and the required controls for us to safely complete our work. An access permit is required to gain access to the part of the network for the required work. A test and ancillary permit is required on the test object, which allows the application of high voltage. On the access permit, there are isolations and earthing to provide safe access to the network. These are checked against the system diagram to ensure they are correct for their purpose. Before testing begins, the GIS must be switched and the earths removed to allow testing. Once the access permit is verified, the physical isolations and earthing are checked on-site to be correct. Once the checks are complete and the access permit recipient is satisfied, the permit is discussed with the work group and they sign on. Earthing is the first thing to be connected onto the trailer at the beginning of setup and the last thing to be removed when packing the trailer away. Next, the test trailer is powered. The test trailer requires a 3-phase 100 amp power supply to run. The lamping procedure is used to check that the power socket has 3-phase supply and neutral present before it is used to power the test trailer. There are operational and safety concerns that prevent running the test trailer without proper supply. The output voltage of the test trailer is monitored by a voltage divider. The arrangement of the capacitors and the inductor produce an output compatible with the voltmeter. The voltage divider is now measured and checked. Checking that these are set up correctly requires a ratiometer. The output is connected to the voltmeter via a low voltage cable to allow the safe verification of the output voltage of the trailer being applied to the test object. In this case, the test object is the 132 kV cable intended for commissioning. The wide copper earthing is used to connect a suitable earth to the measuring circuit. The high voltage line used is standard building wire and is held in place by plastic string or conduit to keep necessary clearances from structures and earth for the voltage being applied. The wire is strung between the test trailer output and the test object, and a manual earth will be applied to the test trailer output as a visual indication that the test circuit is earthed. The trailer has an oil-cooled reactor. The reactor's oil radiators are closed during transport and are required to be opened before the test trailer is operated. The manual earth will now be removed from the test trailer output to make the test circuit ready for high voltage. The exclusion zone around the test trailer, voltage divider, high voltage line and test object are designated by black and yellow rope and danger signs to prevent access to the hazardous voltages used for testing. Observers are positioned in locations to monitor access to the area and warn anyone approaching the area of the dangers present and to prevent unintentional breaches. The test area is now deemed active and ready for high voltage.
Coming on! All clear!
The next step is to find resonance to enable testing of large feeders at high voltage. Finding resonance is achieved through the use of the control panel interface and the software on the laptop, wirelessly connected with the test trailer. A preliminary check is performed at 5 kV before the voltage is ramped up to the required test voltage. The test voltages required for commissioning are defined in the Ausgrid network standard NS161. For the test today, 132 kV will be applied and the test duration is 1 hour. The testing is now in progress and is being monitored by the testing engineering officers inside the control cabin of the test trailer, and the area is being watched by safety observers. Once the testing is complete, the tester in charge will announce that the test set is down and off, and then a manual earth will be applied to the test trailer output as a visual indication that the test circuit is earthed. The power is cut and the pack-up begins. Everything remains earthed and the equipment is packed away. Then we turn off supply, and as a final step, the earthing is detached and also packed away.